welcome back to a continuation of our electrical fault finding video. What I'm going to look at today is we're going to have a bit more of an in-depth look at this switch and see if indeed this is our potential problem. I'll link in the video description of the part 1 to this video. I've got a bit of housekeeping to do to start off with. First of all, I'd like to thank all of those of you that have given me some really nice positive feedback in the comments. They've been really very much appreciated. I'm not the best at explaining stuff always on camera and, well, even in normal real life really, but yeah, having that feedback was really nice confidence boost, and yeah, really nice to hear. I'd also like to say a thank you to a chap called Andy K, who's in the comments of that previous video. His thoughts were that the exits connector is the dash loom, and that goes to the fuse box, which yeah, having a look at the sheet, a lot of these are connected to the fuse box, so yeah, that's totally and utterly plausible, so thank you very much for that, Andy. He also suggested using a 55 watt lamp in place of the fuse, which is a brilliant way of limiting the current and helping you fault find. If we take a 55 watt lamp, power divided by voltage, so power is 55 watt lamp, divided by voltage, a nominal voltage of 12, gives you 4.58 amps. So again, on a 10 amp fuse, with a circuit that's capable of delivering at least 10 amps, is perfectly safe to use. So yeah, thank you very much for that again. On to the last thing now, and that's where we come to this switch. Now, I presumed that the fault was going to be on this switch, and if we go back to our wiring, we can see that our supply comes in from one side of this switch, the other side is connected to ground through the lamp here, and then there's a straight connection from this switch which goes to our two motors. What I completely glossed over is the fact that there could still be a fault on this wire here, although it's currently unplugged from these two motors here. So between here and our switch, there is a potential path to ground through these this wire here, so there is a potential that this is rubbed through to ground somewhere along the line. Excuse me, I'm gonna have to make another cup of tea, I think. So yeah, so that's our switch. That's all I want to say on that. I've got a bit more of a diagram here of our switch. I've got the pin out as if we're looking at it. No, the pins are completely in the wrong place, but the numbers are right. This is how it's shown in the Haynes manual. So fuse 9 comes down to pin 4, pin 3 is connected to ground, which I've not really labelled here. So that's just simply our dash light, which we can light up in here, which we will have a look at in a moment. Fuse 25, which is the circuit we're interested in, this is the fuse that kept blowing. The fault actually cleared when we pulled this out. Again, so we're taking away our 3 connections, aren't we? Or 4 in this case, if you include the lamp. But we know there's nothing wrong with this circuit because this lit up, and we'll look at that in a minute actually. So fuse 25 goes to pin 6, which is this one here, and it is grounded through pin 3, which is the one just above it, and the output of this voltage divider comes out of pin 7. Pin 4 and 3, as I said before, is the 2 lamps. So I've got some wires here. I've got my test light to act as our fuse, so we don't blow this up, or because I don't think, well, yeah, I don't know. I don't think there is a fault. There could well be a fault with this. I don't know. This is what we're here to do. This is what we're finding out today. So we can do some basic preliminary checks. So I've got a digital volt ohm meter here. So if I put it on our ohm setting, if we find a total short, it will display as near as damn it 0. Now this is quite an old meter. These are old leads, so I mean, really and truthfully, that should be 0 because it's a direct short. So we've got to compensate and try and imagine that, or take out that hysteresis, if you like. So 0.6 is essentially going to be 0. So if we test something like our test lamp here, we get 15 ohms. So let's write that down. So we use whole numbers, let's not mess around. So 15 ohms. Let's move that out of the way. Really well done video here, isn't it? So I've written some notes here. There's a really good little pie chart type thing that I've found online, and I'll put it up in the video on the screen for you, so you can have a look at it yourselves. Hopefully I'll remember to put a link in the description to it. Right, so yeah, let's do some testing on this. I've got myself a 12 volt battery here. It's quite old, but it supplies a voltage. So let's have a look at this switch first of all. Got my 2 jump leads here. The yellow being the positive and the black being the negative here. So if I join these up to connection 3, which is our ground on this switch, and number 3, number 4 rather, we should be able to see, or probably not, I can see just in there that the back light is lit up, and if I try and cover this as best I can, I don't know if you can actually see that in there. You can see that is actually lit up. So next we think there's a potential fault in this switch. So because this is a resistor bridge network, we should be able to use our digital volt ohm meter here, and we should be able to test between pins 6 and 7 and see if there's any kind of short in there. Let's bring that there, 6 and 7. There we go. Really good quality video this, isn't it? So pins 6 and 7, if we put our pins across that, we do actually get some very low resistances. Low resistance in this case is quite bad. So it could be, oh, this is so fiddly. My fingers really don't want to work this morning. So again, so if we go between 6 and 7, that's our that's through the whole divider network, if you like. Directly to not 6 and 7, what am I talking about? Sorry, 6 and 3, idiot. Right, so let's go 6 and 3. Now you can see that's 1,000 ohms we got there. So potentially there is no fault there. We'll do a calculation in a minute and see what that equates to, but I can't see that being a problem. I would expect this to be more or less down to near enough zero like it is there. That's what will indicate a direct short. So 6 and 3 is our pin, ground pin, and 6 is our voltage coming in. So I'll just grab a calculator here. I've got some notes here. So if I do voltage, which is 12 volts nominal, divided by 1000, which is our resistance, what's that? Is that 12 milliamps? That's gives us our I, which is our current. So yeah, that's about 1000 ohms is equating to about 12 milliamps. So at the moment, that's giving me a confidence that I can connect pins 6 and 3 across this battery and it not actually cause it to overheat, let out the magical smoke, whatever. So what we'll do, just to be absolutely sure, we'll put it through our test light here. So if I put that through there, you can see the test light lights. The light is going to act as our safety net, as our fuse resistor, however you want to call it. So again, if we go between 6 and 3, so since 6 is our negative and our test lamp is on the negative side, we'll connect that to pin 3. Hopefully we'll get a good connection. And then the positive will go to pin 6. Now, the test light isn't lighting. That's exactly what we was expecting. Because we don't believe the fault is not on this part of the circuit. So we can now be confident to disconnect the test lamp out of the circuit and then put our ground pin straight onto our pin 3 just there, and our number 6 is the positive. So what that should give us now is, this is, as I said before, this is acting as a voltage divider. The switch part of this switch is actually switching in different resistors. I'm not going to go into how a voltage divider works. I'm not really the best person to explain that. I'm barely explaining this, to be honest. So if we connect, we know our test light, we know our headlamp motors have a positive and a negative connection. I think the negative connection to the G connection is going to be the important one in this case. The positive, I think, is just a power feed to the motors. So if I now go put this in onto our negative connection here, let's see if I can make this work, and put our positive to pin 7, which is okay, right, that's that clamped in. So if we go pin 7, which is our bottom one, we should see a voltage. It's on the 0 setting at the moment. So if we put that to pin 7, we've got 12.8 coming straight out of this pin. I'm assuming it will go 12.963 as a guess. I think that's how this will probably potentially work. So that I am now on number 1, and you can see that's dropped down to 11.25. Okay, that's fine. Go down again, 10.35, and lastly 8.91 on the last setting, which is number 3. So each position does indeed generate a different voltage. My ranges were obviously totally off, and to be fair, I didn't make them up. It was just something that I was expecting to happen. So this shows that this switch is working exactly as intended. I can't see any problems there. It's not burning out my leads or anything, which is, well, it's good really, but it does mean that we have got a potential fault on the wire on the car going back to those motors to the headlamps, which are still disconnected currently. And remember, we had those disconnected when we were trying to find the fault, so that does mean that our lead that goes to this G connection from this switch does indeed potentially have a fault to ground somewhere. One thing that I forgot to say about earlier, as part of my housekeeping, was when I disconnected the X6 connector, I was potentially clearing the fault, and the reason for that is these connections through this switch, all three of these, and potentially all four, actually goes through that X6 connector. So when we was disconnecting that, it was disconnecting all of the connections and not just one side of this switch. That's why the fault was totally clearing when we disconnected that. So I just wanted to point that out. So this means that we'll be working on the car again and seeing on our pin 7, seeing if we've got a direct path to ground on that pin 7. So let's go and have a look at that next. So here we are back at the car again. Got the test light connected to ground at the moment. I've got this yellow lead connected to the other end of my test lamp here. As we said before, pin 6 is our positive feed coming in. So if we test on pin 6, which is on the right hand side here on the switch, that means it's left hand side in the socket. So if I put my positive lead in there using my T-pin and turn on the headlamps, sure enough we get a good test light. That's what we expect. Now if I swap that over and take my ground lead off and ensure everything falls on the floor and connect up to pin 7. Pin 7 is the one on its own at the bottom, which is on this right hand side here. Lights are off at the moment. Now we need to be careful that we don't short these guys out. There's plenty of distance between them, so we should be okay. Now when I turn the headlamps on, we shouldn't have anything on this test light, and unfortunately we do. So that must mean we must have a path to ground between the headlamp motors and to this point here. Test lamp is now connected to battery positive. As soon as it finds a ground, test light lights. We've got our headlamp monitoring motor plug here. Got our yellow wire, which is from fuse 25, our brown wire, which is obviously our ground. So if we put that to our ground there, test light lights. And then we've got our yellow and brown wire, which is our motor leveling output from the switch. If we connect that here, as you can see, test light lights. So now we've got to find that there's going to be a rub through to ground on one of the wires somewhere. Okay, test lamp is connected to battery positive and is now connected to the brown and yellow lead here. What I'm just going to do is I'm going to start taking this grill off. So I've got you set up where you can still see the test light there. This is the wiring harness that runs along the front here, and you can see that some of these wires are actually, some of this protective coating is gone sort of brittle. So I think the best thing to do is try and pull this about and see if we can make the light flicker. I've got nothing there so far. This end here should go directly to our other socket here, so we could probably put the test light there and see if that light's there as well. In fact, let's do that. You probably can't see that very well because of the sun, but the test lamp is still lit. We've got that connected to the brown and yellow wire on this end as well, so that shows that there's continuity going back all the way down to the switch there in the dashboard. So what that indicates is we haven't got a break here on the front, but somewhere along the line we could have some kind of rub through, which I strongly suspect is what's happening here. So I'm going to continue to pull these wires about and see if we can make that light flicker. Okay, you can probably just about see the test light there, but when I play with the wires just up here, you can see that we can make that test light flicker. So we've obviously got some kind of rub through to ground underneath this washer bottle somewhere. Looks like we're going to have to take the battery out temporarily just to get to the bolt to undo this and give us access to underneath that bit of wire. So yeah, let's do that next. You're going to have to excuse handy cam for a minute, but I don't know if you can see that just in there. I'll get you in the right place. Ignore all the leaves in here, it does live under a tree. This is our fastener for the washer bottle, and if I get further in there, I don't know if you can see that there's some wires actually clamped underneath that. I suggest that's where our problem lies. Can you even see that? There we go, there's a better view for you. I've never had this washer bottle out, so yeah, this has happened before I've had it. Now, it's quite hard to get a decent angle on this. You can see some of the corrosion here, and here if we look just down here, we can see that we do actually have some green crusties. Now if I peel some of this harness stuff away, and sure enough, there's our wires. It doesn't look like it's gone through though. I don't know if you guys can see that in there. Let me just check the screw. As I was saying, if you have a look at this brown and yellow wire here, you could just about see that that was indeed being crushed by this washer bottle mounting. And I bet you that's where our problem has been lying. The good news is it don't look like it's damaged the wire all that much. We've also got a ground connection that was also trapped under there with it. What I can't yet see is if there's any actual break in the insulation. It does look like there might be the slightest bit there. Yeah, I think I can see a little bit just right on the edge there. Probably enough over time where the edge of that bolt rubbed through and actually met its way to the exposed cores there. So we might get away with just putting some tape around that. Not the best of repairs, I know, but this harness is well in there. You can't really pull it out at all to get decent access to it. Not without disconnecting more stuff, probably. Okay, battery is temporarily back in. We've still got our test light connected in. And now when we wiggle these connectors around, we get nothing on there, which we expect, because I'm absolutely certain that washer bottle bolt was the one that was causing that rub through that wire and giving our path down to ground. Now I'm going to start reconnecting these. As you can see, the light is off at the moment. We need to put our switch back in as well, so let's get these guys reconnected. So I'm absolutely confident that we've found the fault now. We could put the little levelling switch back in, and then we'll turn the headlamps on. Okay, so that's the headlamp levelling switch back in. Lights coming on now. I don't know if you can see that or not, but no blown fuse. Let's see if these move up and down with the level switch. Fingers crossed it will. I'm sure it will. Right, okay, I've got you very crudely set up under a cover there. I've got my second microphone that I've put next to the headlamp levelling motor. If you guys can tell me when you see that move, and maybe even hear it as well, it might be a good idea that I shut this up as well. Right, there we go, ignition on. Although we don't need the ignition on for this, because when you look at the wiring diagram, you can see that no, it doesn't need it. Okay, so we're on 0 at the moment, so here's number 1. I can hear that move from here. Number 2. Number 3. Brilliant. That sounds like that they are working. Hopefully you guys can see that moving. I can't because of the bright sunshine. So I'm going to go back all the way up to 0 now. And I can hear them moving absolutely fine. Back to 3. Yeah, perfect. I'm happy with that. Let's go and fix that wire. So I just noticed that I was coming in a bit hot on the audio there, so apologies for that. I've got some Tezza tape here. This is something I've had for a little while. It's like a cloth based tape, very similar to the original stuff that Vauxhall have put on their wiring harness. I've used this stuff before to make my own wiring harness for something, and all I need to do is just find the end here and then hopefully we can wrap it around there, which I think is going to be easier said than done because it's in such an awkward position. I think what I might have to do is just tear a length of this stuff off and do the best I can. Okay, so let's try this trick here. Just wrapped a load around this this here, which is going to be more of a pain, I'm sure. Okay, so if we start off where the last one ended, give that a couple of wraps, just make sure that it's secure and that the whole thing is wrapped in our stuff here. There we go. I bet you guys can't see a thing what I'm doing. Trust me, I've got hardly any access here myself, so bear with me. Not one of the best jobs in the world, but it's all nicely clean, sealed up using this Tezza tape here. So all that's called for now is getting this battery back in, putting the front grille back on, and then giving it its final test. Okay, so that's finally this electrical fault finding video come to a nice conclusion now. Finally got it finished. The first video was really there for how to fault find really, and it was getting rather long, as I suppose this one is, as usual. So all that's left now is turn the headlights on. Battery and that is finally back in, grill's back on. I've removed nearly all my tools, so now we just need to turn the lights on and give it a final test. Okay, headlights on. I can hear them. That's everything back together, given the headlamps a final test. Thank you very much for watching, and I'll see you again in another video.